Lastly, we will consider another circuit topology of water distribution systems to represent the buck-boost converter operation. Once again, take note of the new location of both controllable and uncontrollable power switches. According to the consumer's demand, System A will perform the buck function while System B will execute the boost function. When switch A and B are turned on, we can see there is a direct connection between the utility and water generated tanks only. Hence, this condition is similar to the operation of the boost converters when the transistors are turned on. However, when we look at the water volume generated by the water generated tanks, we can see these systems are using a different approach. Instead of generating an additional volume of water, these water generated tanks have a similar water volume to the consumer tanks. The reason of this condition will be answered when the switch A and B are turned off. As you can see, when both switch A and B are turned off, the consumer tanks only connected to the water generated tanks only. The water generated tanks will be the sole water supply to the consumers. That's why the water generated tanks need to generate water equals to the consumer's demand. Based on the connection between the water generated tank to the consumer tanks, it is similar to the connection between the inductor to the resistor in a buck converter operation. However, throughout the system operation, we can see there is no direct connection between the utility tank to the consumer tank. Therefore, in the DC converter circuit, you will see there is no direct connection between the load and the DC supply whenever the transistor is turned on or turned off. Therefore, the converter is also known as the indirect DC-DC converter. However, as similar to the previous converters, the duty cycle is always directly proportional to the demand. To perform the step-down function or buck operation, the duty cycle must be less than 0.5, and to perform the step-up or boost operation, the duty cycle of the converter must be higher than 0.5. I will end this video with the comparison between all DC-DC converters. As we can see, all converter circuits have the same components except the connection of power switches.